All right, section 3.5. We got 40 minutes to finish 3.5 and 3.6. These are a lot easier though. 3.4 was the big one. So 3.5. All right, slope. So graph a line with the indicated slope and y-intercept. I wish they made that graph a little bigger for us. I think I'm going to go back and blow it up. Slope 2/5, y-intercept 0. Okay, so slope 2/5, y-intercept 0.7. Okay, so yeah, this should be, this isn't really anything that, slope is 2/5, y-intercept is 0.7, or was it -7? 0.7, slope 2/5. Okay, yeah, so they want you to basically graph given that information. So this is question number 1 here. This is section 3.5 now. So how do we do that? Well, you know how to do this already, right? Let's start with the y-intercept. Can we put him on the graph? He's just right here, huh? At 7. Over 0, up 7. Remember, the first number's over. Second number's up or down, right? When you do the two numbers with the comma. First number's over. Goes sideways first. The second number's up or down. So there's over 0, up 7. There's that dot. Right there. So now, how do we get, that's the first dot. We need 2 dots to make the graph. They want the line. They want the picture of the line. So you got to have 2 dots, right? So how do I get my second dot? Yeah, you do the rise and the run. Remember, slope is rise over run. So go up 2, 1, 2, over 5. 1, 2, 3, 4, 5. Remember, we're counting jumps, right? Not lines, but jumps. So jump. So 2 jumps up, 5 jumps over. Right there is our other point. There we go. And then Math Excel will automatically connect the dots for you. There's the graph. Is that easy enough? Not much new there, right? Just start with the y-intercept over 0, up 7, and go up 2, over 5. And you've got up 2, over 5. You get the second point. Connect the 2 points. All right. Questions on that? Good. All right. We'll keep moving. Got that down okay? Okay. So let's try this one. So slope -4/9, y-intercept 0.7. Okay. Try that one. Same kind of thing. They want you to graph. Slope is -4/9, y-intercept is 0.7. Can you graph that one? So we need the 2 dots, right? The first dot is the y-intercept. So first put the y-intercept on there. So 0.7 right here. There's that one. Good, there's our first dot. First dot's always on the middle line, over 0, up 7. Now from there, we need to march off the slope to get to the second dot. Now how do we get to the second dot? What do you do with a minus that's in front of a fraction? Like what do you do with this minus in front of this fraction? Put it on the top, right? Now you could put it on the bottom, but I think it'd be easier for you, just put it on the top. Doesn't go on both, right? Because 2 negatives would be positive, that'd be wrong. But put it on the top only or the bottom only would be correct. I usually go with the top, it's easier. So remember, it's rise over run. Can you do that one? So go from that first dot, do the slope to get to the second dot. Rise over run. So what am I going to do? Down 4, huh? 1, 2, 3, 4. Down 4. Over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 4 over 9. There's the 2 dots. Connect the dots. And there's the line. Easy enough? Questions on that one? So that's what other stuff is stuff we've done. Okay, so here on number 11, we have 2x minus y is 3, and they want us to graph it. What have we learned about how you get a picture, get a graph, when you've got an equation like that? Yeah, what do we got to do first? We've got to get y alone. Yeah, first get y alone. So first get y alone. So go ahead and go through the steps there. First get y alone. And then go to the graph. So subtract 2x from both sides. Is that good so far? But you got to get rid of that minus on the y, huh? How do we get rid of that minus sign that's on the y? Divide through by -1, huh? And you got to go all three whenever you divide like that. Is that good to there? Divide through by -1 all the way across. So y equals, right here, 2 negatives. Positive, and 1 negative, negative. Is that good? So we got y alone. Now why are we so into that? Well, because then this out here is where we start. Down 3 in the middle. And then the other part, you put over 1, and it's rise over run, huh? It's just like what we did now. Now that you've got y alone, it's you know how to graph it, huh? Can you finish it from there? On the graph. So we start down 3 right there. There we go. Down 3. And then from there, where do we go? Rise 2, run 1. So go up 2 and over 1. Be right there. So I went up 2 and over 1 on that. Is that good? I don't know if I can even draw it that small. Yeah, I'm not going to try. Up 2 and over 1. Whoops. And then we connect the dots. Or Math Excel will do that automatically. So there's the graph. We did some of this yesterday, right? You good with all that? Questions I can answer on that one? But it's always about getting y alone. You get y alone, and then the number off to the right is your starting number, down 3, and the other number is your slope, rise over run, up 2 over 1, right? I went up 1, 2, over 1, up 2, over 1. To get from the first dot to the second dot. All right. Okay, yeah, so this one, they want you to find the slope between those points. So do the same thing. You know the slope formula that we've been using all day, all morning. y2 minus y1 over x2 minus x1. Go ahead and do the slope formula. Something weird's going to happen. So I want you to see this one, so you can know what that means. So this is our x1, y1, x2, y2. So y2 minus y1. So what's that? Careful with your signs. Minus 10 minus minus 4 over x2 minus x1, 10 minus 10. So what do we got then? You got to be a little careful. These two negatives right here become positive. And so we get negative 10 plus 4 over 0, which is minus 6 over 0. And what's that? Undefined. Remember how 0 underneath undefined? So we would choose this option, undefined slope on that one. Is that good? So just making sure you know that one's an undefined slope. 0 underneath is undefined. What kind of line is that? Straight up and down. It's instead of sideways, perfectly sideways, straight up and down. How do you know? Remember, it's rise over run, right? If you're ever looking at a slope, remember it's rise over run. What kind of line has no run? Run is sideways movement, right? What kind of line doesn't go sideways at all? Straight up and down. No run, no sideways. Right? It's got to be straight up and down, doesn't it? Good on that? We good with all that? All right. So here's number 20 in section, what just happened? I hit the button. 3.5. So we're on number 20 and 3.5, right. So here it is, and basically they want us to find the slope, just slope. So how do you find the slope? Whoops, that's off the, is it off the screen a little bit? Oh, there it is, that's 8, okay. That's 8, good. So each of these, this must be 1, 2, 3, 4, 5, 6, 7, 8. And this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, I can't tell what that point is. I can't tell what either one of those points are. Those points look off to me.
Yeah, the points are right there.
Oh, they're showing them on the bottom. Yeah. Well, part of them, huh? Yeah, okay. Didn't notice that. Okay. So, yeah, you just use these numbers. This is your x1, y1, x2. You don't even need to look at the graph. x1, y1, x2, y2, slope. So this is number 20 in 3.5. So slope is y2 minus y1 over x2 minus x1. So slope is this minus this. It's at 446,006 minus 273,003 over 3 minus 1. x2 minus x1. So, I don't know, whatever, I'm going to go dot, 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 whatever your calculator says, hit the buttons. That's all they want. That's all they want on that one. Just slope. They say it weird. They say rate of change, but that's what it means. Because, maybe I'll mention that for a minute. Yeah, when they say rate of change in the population, they're basically asking, how fast is the population in this city changing? Rate of change of the population. That says rate. Rate. Rate of change. That's the words they use. How would you know when you read rate of change in the population that they mean slope? Well, have you ever thought about it before? That how fast you do something is always a fraction. It's always one thing over the other. If I say I can drive 50 miles per hour, that's 50 miles over 1 hour, right? Or I can grade 10 papers 10 problems per minute. 10 problems over 1 minute, right? I can solve 3 problems per hour. Hopefully you're faster than that. 3 problems per hour, right? Whenever you have a rate, that means a fraction with time on the bottom. That's what all rates are. Did you ever stay up late at night thinking about that? Think, wow, rates are slopes. Probably not. That's what weird math teachers do. But it's true, isn't it? So whenever they ask you for a rate of anything, that's a slope. That's a fraction. Rates in the real life world are slopes on graphs. That's what they are. So when they say rate of change, they want population per year. They want to know how many people per year is the population change? Are there 50,000 more people in this city every year or whatever? Population per year. Y over X. Population is Y. Y values. Years are X values. It's a slope. That's a slope. Fancy words, blah, 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 find the slope. That's what they're saying. That's all you got to do. All right. Okay.